This is an algebra lesson called partial fraction decomposition. So no calculus in this. Partial fraction decomposition is when we take a fraction like 2x plus 16 over x squared plus x minus 6, and we find some fractions that add up to this fraction. So when we're all done, I'll repeat what the goal is. To achieve the goal, we start by factoring the denominator. X plus 3, x minus 2. Is that the same as x squared plus x minus 6? So the denominator is factored correctly. Then we say this fraction, 2x plus 16 over x plus 3 times x minus 2, can be written as a over one of these factors plus b over the other factor. Where a and b are two numbers, I just don't know what the numbers are right now. Now we have this equation. We're going to multiply both sides of this equation by the common denominator. The next step would be one you should be able to do in your head, but I'm going to write it down. This is the common denominator. Multiply that by this side of the equal sign, 2x plus 16 over x plus 3x minus 2. So we have to multiply the other side of the equal sign by the same thing. Common denominator times a over x plus 3 plus distributing, so common denominator times b over x minus 2. And now what we have is an equation that won't have any fractions, because the left side of the equal sign is just 2x plus 16. The right side of the equal sign is x minus 2 in parentheses times a plus x plus 3 times b, because of this yellow. So checking this, 2x plus 16 equals x plus 2 times a plus x plus 3 times b. Next thing we do is let x equal any number. You really can use any number you want here. Pick a number out of the blue. I'm going to use 2. You really can use any number. I'm not kidding. Replace all the x's with 2. And probably you could do some of this in your head. Don't need to write every single thing down. This looks like 20 equals 5b. That's 20 equals 0a plus 5b. So now we know 4 equals b. And then we go back to this, and let x equal some other number. Any number, really. I'm going to use -3. Replacing every x with -3. 2 times -3 plus 16, I'm using the purple, equals -3 minus 2 times a plus -3 plus 3 times b. replaced every x with any number I felt like. I felt like using -3. This is -6 plus 16, which is 10. This is -5a plus 0. So -2 equals b. So here's what we mean by partial fraction decomposition. We had a fraction, 2x plus 16 over x squared plus x minus 6, and we decomposed it. It's the same as a over x plus 3, error, this is supposed to say a right here, sorry, so back up here. It's a over x plus 3, that means -2 over x plus 3, plus, right here, it says b over x minus 2, b is 4. That's it. This is the decomposition of this fraction. Add these two fractions, it's going to equal that. That's the answer. So to check, if we add these two fractions, it's supposed to equal that. If we want to add 2 over x plus 3 and 4 over x minus 2, we can't add these like this. They have to have the same denominator. The common denominator of these two fractions is x plus 3 times x minus 2. It's the same denominator for both. It has to be in order to add them. What did I multiply to this denominator to get the common denominator? Whatever I multiplied to the bottom, which is x minus 2, I have to multiply the numerator by the same thing. What did I multiply to the this denominator to make it the common denominator? Whatever I multiplied to the bottom, the x plus 3, the top has to be multiplied by the same thing. If you cancel these x plus 3's, we're back up here again. If we cancel these x minus 2's, we'd be back up here again. But we don't want to go back up there. We want these to be the same denominator. This numerator plus this numerator all over the common denominator. I just wrote numerator plus numerator all over the common denominator. Combine like terms, -2x and 4x is 2x, 4 and 12 is 16. X plus 3 times x minus 2 is x squared plus 1x minus 6. Check. It's true that if you add these two fractions, it equals this fraction that we started with. Partial fraction decomposition. I'm going to do just one more. 1 minus 3x over 3x squared minus 5x plus 2. We're going to decompose this. That just means we're going to find fractions that add up to this fraction. First thing is factor the denominator. 3x squared is 3x times x. 2 at the end here is either 2 times 1 or 1 times 2. Alright, we're going to use -2 times -1, because -2 times -1 is +2. And outers, -3x. Inners, -2x. That gives -5x, which is correct over here. So now that the denominator is factored, we're going to say this fraction, 1 minus 3x over 3x minus 2 times x minus 1, can be written as some number over one of the factors plus some number over the other factor. Just don't know what these numbers are yet. So we're going to multiply both sides of the equation by the common denominator. Here's a step you should do in your head. The one that I'm writing down right now. Common denominator times the left side of the equation Alright, so I have to multiply this side of the equal sign by the same thing. Common denominator times, I have to distribute that to multiply to each term. X minus 2 times x minus 1 is the common denominator. We're just multiplying both sides of the equal sign by the same thing. And the left side of the equal sign times the common denominator is just 1 minus 3x. This fraction times the common denominator is just x minus 1 times a. And this third term times the common denominator is 3x minus 2 times b. So when I say in your head, I mean, I'm hoping you can go from this step right to that without writing all this down. But if you need to write it down, then write it down. Now this is the fun part because you really can let x equal any number you want. If you want to make x 7, it's going to work. I'm going to use 1. So everywhere there's an x, we're going to put 1. Do some of this in your head. The left side of the equal sign is negative 2. And the right side is b. Because that says 0a plus 1b. There you go, that's what the b is. Let x equals some other number. Any number you want. Now, the clever people will use 2/3. Because when x is 2/3, this will be 0. But I just want to show you that if you don't think of that, any number works. I just put 0. When x is 0, the left side of the equation is 1 minus 0. When x is 0, the right side of the equation is negative 1a minus 2b. Because 0 minus 1 is negative 1. A. 0 minus 2 is negative 2. Negative 2b. And the thing is, right here, the b can be replaced with negative 2. You just get that right there. 1 equals negative a plus 4. Negative 2 times negative 2 is positive 4. I'm going to add a to both sides and subtract 1 from both sides. A equals 3. So here comes the partial fraction decomposition. We started with this fraction, 1 minus 3x over 3x squared minus 5x plus 2. That equals a over 3x minus 2. A is 3. Plus b over x minus 1. Right here, b over x minus 1. B is negative 2. That's it. This is the partial fraction decomposition. Let's check. This fraction plus this fraction. If we add these, we should get the original. You can only add these when they have the same denominator, which is 3x minus 2 times x minus 1. What did I multiply to this denominator to make it the common denominator? Whatever it is, the top has to be multiplied by the same thing. What did I multiply to this denominator to get the common denominator? I have to multiply the numerator by the same thing. So I see that if I cancel these x minus 1s, we'd be back up here again. If we cancel these 3x minus 2s, that would be back up there again. We don't want to cancel because we don't want to be back up there. We need the same denominator. So the numerator of the first fraction plus the other numerator all over the common denominator. Distribute. This is 3x minus 3. This is negative 6x plus 4 over 3x minus 2 times x minus 1. Combine like terms. 3x minus 6x is negative 3x. Negative 3 plus 4 is positive 1. Multiply these binomials. That's 3x squared. Negative 3x and negative 2x is negative 5x. Negative 2 times negative 1 is positive 2. I think this is the original fraction. Check. But the answer is up here. It's in the red circle. It's the decomposition of this fraction, partial fraction decomposition.